Hi, a very good morning. This is Dr. Sajja Suneel from Data Science Department. Today I am here to discuss you about characteristics of IoT as well as the physical design of IoT and what exactly IoT. As I told you in my previous classes as well as from starting of the course, we are discussing IoT stands for Internet of Things, and there is another synonym for this particular Internet of Things was Internet is everything. And in this Internet of Things, there will be a certain physical, logical design as well as there are some characteristics which are required for this particular IoT. Today we are going to discuss about these characteristics and physical design of IoT. Let's have a quick view regarding the things which we are going to discuss today. See, these are the topics which are presented in our introduction to Internet of Things. From these topics, today we are focusing majorly on characteristics of IoT as well as physical design of IoT and different kinds of IoT protocols. These are the three topics which I am going to focus today. Characteristics. What characteristics are? For any kind of thing, there are some characteristics. For suppose what this pen characteristics are, what this device characteristics are. Like that in IoT also there are certain characteristics which has to be considered. And in the same way, there is a physical design for any kind of IoT devices. What kind of physical device designs are there which are existed in our IoT, and there are some protocols which are required to communicate from one layer to another layer to exchange the information in form of data. For that particular purpose, we require some protocols. And in the coming classes, we are going to know about these particular protocols and have a look about the characteristics of IoT and the physical design of IoT. And coming to this module, if we finish this particular module, what we are aiming and what we are going to get as an outcome, we are focusing to know about some concepts as well as the characteristics of this particular IoT and the physical design. And you guys are going to familiarize about different kinds of IoT protocols as well as communication models and application programming interfaces. There are different kinds of application programming interfaces. We are knowing about this, and also we are going to explore different kinds of IoT enabled technologies and their applications in different domains. These are the objectives which we aimed for. And coming to the outcome, students will be able to define what exactly IoT was and how to explain its characteristics. And also students will be able to understand the different kinds of IoT communication protocols, and they are going to identify as well as they are analyzing the domain specific IoT. Domain specific IoT is nothing but the specific IoT system which we designed on this particular IoT. There are multiple levels as we discussed in some other classes as well as in previous classes. We have discussed about IoT level 1, level 2, level 3, like that 6 different kinds of levels are there. Each level stands for a specific domain IoT, which is going to be discussed in my future classes, which is domain specific IoT part 1 and part 2. Check it out for reference. And in this level 1, we discussed about home automation system. In this home automation system, the devices are going to capture the data which is in the form of videos or in the form of images. From that particular data, we are going to analyze the things. These things are going to be known to us once after finishing this successful module. Let's go into the details. What are the different kinds of characteristics which Internet of Things should be considered? The first one is it should be dynamic and self-adapting. How we can call that particular device was dynamic, and how it has a self-adapting capability, how the device is self-configurable. Most of you guys are using electronic gadgets, right? Everyone nowadays are using some electronic gadget, some smartphone. Take a consider as an example. In the smartphone, how it is automatically self-adapting the things, how it is automatically dynamic, how it is automatically self-configurable, how it is automatically having some kind of protocols which are supporting to transfer information, whether the device is having any kind of unique IP address. Yes, these are all the characteristics what our IoT system consists of. That is what we are discussing here today. The characteristics of IoT. The first characteristic was dynamic and self-adaptability. The second was self-configuring. And the third was interoperable communication protocols. And the fourth one, unique identity. And the fifth one, integrity into information network. These are the 5 different types of characteristics which are there in our IoT. Once have a look what dynamic and self-adapting was. Adapting. For suppose in my olden days, I'll take a real-time example. Why? Because I was a 90s kid and you guys are young generations who are 2K kids. And coming to the scenario, we have adapted to different kinds of environment at my childhood. I don't know what this 2G, 4G, 5G was. We are to make some phone call, we need to go to some coin box, or else we need to go to some post office, and to make a call like that some telegram has to be sent like this. Some things are there. And after that, at my middle age, at my young age, I found some coin boxes, I found some telephone booths. By going there we are talking. And after my what we call engineering age, I came to know that there was a cell phone, which is the introduction of 2G. At that time, we have not smartphones. We are only having a normal phone, which is used for sending messages, which is used for placing calls, like a 1100, Segam, like that. Multiple mobiles are there. And after that, we entered into smartphone world where 3G came into existence. At that time, smart mobile phones came into existence. After that, 4G. After that, 5G. Now 6G was going on. Maybe tomorrow the generation will be more high compared. Why? According to by generation, we are adapting towards that particular trend. This is what self-adapting was. In the same similar way, our IoT systems are also able. It should be dynamic and it should be self-adaptable. These are the things. And see here, by this particular characteristics, we are able to changing the contact, as well as we are going to take some actions on the based on the conditions. Example, automatic adjustment of surveillance, which is going to be done by based on image quality, based on motion detection. For suppose there are some vehicles which are placed in your parking area. The vehicles are which are placed in parking area are going are misly parked, or else while parking that particular car, if there is any kind of accident has happened, automatically the surveillance camera which is placed over there in parking area is going to identify that so and so vehicle driver has been rashly driven the car and make damage to so and so car. Automatically see the image once here. It was a normal IP megapixel, and this was a analog CCTV, and this was a consumer grade camera. In HD CVI only we are able to track this particular vehicle number in detail. This is how automatically it is adjusting by itself that something has happened by basing on motion detection. Got it, guys? This is how our IoT systems are dynamic as well as self-adapting feature. Have a look. The next characteristic was self-configuring. As I told you, nowadays everyone is using electronic gadget, which is your mobile phone. In your mobile phone, most of you are well known that your mobile gadget is going to update. It is going to configure itself whenever there is an OS update. It is going to show you in some form of a message that an update was there. You want to upgrade it or no? If you want to do it now, you do it now. If you want to do it later, if you click on later. This is how the devices are self-configuring itself. The device is configuring by own self, as well as it is setting the network upgrade also with the minimal user intervention. The minimal user intervention, without user interruption, it is not going to be authorized. Why? Because it's our gadget. It's the person who is using, his intervention is required to upgrade the updated software into that particular mobile. Why? Because like that the configuration settings has been made. Example: Android mobile auto update, auto focus on forces in group photo. You guys mostly seen while taking a group photo. If you want to focus on particular, if you click on that particular image, it is going to autofocus where exactly the faces are. That is how the devices are making themselves as a self-configurable device. This is the important characteristic in our IoT. And next we will go for the next characteristic, which is interoperable communication protocols. These are the protocols which are able to communicate with the IoT devices which are placed in the IoT infrastructure. Have a look here. In this IoT infrastructure, I am using a car as well as my home, and there will be RFID, and here also there are some devices which are connected. In this, the communication between these devices are going to be made by using this interoperable communication protocols, which are presented internally in the IoT infrastructure. See, the next characteristic was unique identity. Every IoT device which is placed in the infrastructure, each device is having a unique IP address. For suppose, observe this Wacom which is placed in front of you. This Wacom device is a part of IoT system which is having an unique ID, and this Wacom wireless pen is also having an unique ID, and the smart gadget which is used by us is also having some unique ID. Like that, every electronic device which is used in our IoT system, IoT infrastructure will have an unique identity. That unique identity will be considered as an IP address or else URI, allowing by querying the device, and also for monitoring the state of device, and also for controlling and configuring them remotely. These are the three things which are going to be done by the unique identity characteristics. See here in the form of a diagram. See here how the things are. There are some three devices which are connected to router. Here there is a router. From our IoT infrastructures, there are three devices which are connected. The first device is laptop. The second one is Raspberry Pi Kit, and the second one is ESPS266 device, which is a part of IoT infrastructure device, and this one is Raspberry. This one is Raspberry, and this one is ESP8266, and this is Lappy. And these devices, three devices, are having an unique IP identity, such as these things. 1, 2, 3. All the things, all the three devices are having an unique identity. If you observe, each one is different from one another. The last characteristic was integrated into information network. In this integrated into information network, whenever we are communicating or exchanging some kind of information with the other devices which are already there in the IoT infrastructure, the device should have some specific qualities. Those qualities are dynamic discovery of other devices. Dynamic discovery means it has to detect the devices which are nearby, and also it should have a capability of describing itself and also understanding others, and also it should be capable by interacting with one another. These are the three qualities, basic qualities, which a device should consist in the integrated in information network. This is the last characteristic. This is the representation for the same diagram has been shown here for representing this particular characteristic also. These are the 5 different characteristics which are existed in our introduction to IoT. Now we will move to the next part, which is physical design of IoT. What physical design of IoT was? The things which in IoT usually people will call IoT devices, right? Take an example, surveillance system in our organization. If you consider the surveillance system in our organization, how the things are, there are n number of surveillance cameras which are placed in all departments as well as in classrooms as well as in labs, right? Every device is having the characteristics which we already discussed in the previous time, and also these things whatever the surveillance cameras, we call them as IoT devices, which have unique IP address, and these devices are able to sense automatically, which is remote sensing, and also they are able to transfer information with the help of actuators, and also they are able to monitor the things such that we can confidently say that the devices which are used in our IoT, by with the help of sensors, with the help of actuators, and also with the help of what we call monitoring capabilities, these devices are going to communicate with each other. Every IoT device is going to have such things such as exchanging information, or else collecting information, or else transferring the data, which is sending some information to your nearest neighbors, as well as perform some specific tasks which are going to be done by it. This is how the things are going to be happen in our physical design of IoT. Now we will have a look how the general block diagram, which is going to be placed in the IoT infrastructure in our IoT device. Have a look here once. See, this was the Raspberry Pi kit motherboard, where it was shown to you in the form of a diagram. And see here, if you observe the things, every device should consist of several interfaces as well as several connections which are wired. Even it doesn't mind. IoT can use both wireless as well as wired connection. So we need an interfaces, multiple interfaces in our IoT device. See here, every IoT system should consist of I/O interfaces for sensors. I/O interfaces are nothing but input and output interfaces which are used for sensors, and the interfaces for internet connectivity also. And also there are some memory and storage interfaces, and there are some audio and video interfaces. Like that, multiple interfaces are required in an IoT system. See here, it was shown to you in a diagrammatic representation. Connectivity interfaces, processor interfaces, audio video interfaces, I/O interfaces, storage interfaces, graphic interfaces, memory interfaces. Like this, multiple interfaces are required in a particular IoT system. See the connectivity. We are having USB host RJ45. If you go for processor interface, CPU. If you go for audio video interface, HDMI port, 3.5 audio jack, RCA video. If we go for input and output interfaces, we require what? We require SPI, we require I2C, we require CAN. If you go for storage related interfaces such as SD cards, MMCs, SDIOs, and if you go for graphic related issues, GPU, which is graphical processing unit, which plays a major role whenever you are performing game related analytical process, and also the memory interfaces such as NAND or NOR, and also DDR1, DDR2, DDR3. Like this, there are a lot of advances which are happening in memory interfaces also. These are the different kinds of interfaces which we people are using in the physical design of our IoT system. Once have a look how IoT protocols are established. In this IoT protocols, as I told you, each protocol is going to give you, each protocol is used to establish a specific connection between our IoT devices and cloud-based servers over the network. These protocols are going to help us for sending some commands, or else for communicating between from one layer to other layer by the help of internet. Without internet, nothing is possible in Internet of Things, as I told you in the initial state itself. See here, what are the different kinds of protocols which are used in multiple layers. First, we consider application layer. In this application layer, once again, we will discuss these things in detail. Now, I am giving you a fast narration about these particular layers and the protocols which are used in each layer. Once again, we'll discuss in the coming time in detail, like what HTTP was, what COAP was, and what the WebSockets was, what MQTT was, what DSS was, and what AMQP was, what TCP, what UDP, all these things in detail in the coming discussion. Have a look here. Application layer. What application layer was? Application layer was the thing which is presented in one of the layer which is in computer networks. In this particular layer, for transferring information through this layer to other transport layer, we require some protocols such as HTTP, Hypertext Transfer Protocol, Coaxial Protocol, WebSockets, Message Queue Telemetry Network, XMPP, as well as DDS, AMQP, Advanced Message Queue Protocol. And coming to transport layer, there are only two different layers. One is Transmission Control Protocol, another one is User Datagram Protocol. And coming to the next one, network layer. What network layer was? IP version 4, IP version 6 low power wireless PAN area network. And coming to link layer, there are multiple protocols such as Ethernet, Wi-Fi Max, 2G, 3G, LTE, which is 4G, 5G, like this multiple things, and 802.11, which is our Wi-Fi network, and also 802.15.4, which is less ratio wireless PAN area network. Like this, multiple things are required in each layer. There are four different kinds of layer which are existed: application layer, transport layer, network layer, link layer. These are the four layers which are existed, and in these four layers there are multiple protocols which are used for exchanging some information through the devices with the help of internet. Have a look. These are the protocols which are listed down. As I told you, Ethernet, Wi-Fi, WiMAX, LR, WiPAN, and 2G, 3G, 4G services are presented in link layer. And coming to network or internet layer, only three different things: IP version 4, version 6, and 6 low wireless PAN area network. Coming to transport layer, we are only having two layers. One is TCP, and the other one is UDP. Transmission Control Protocol, User Datagram Protocol. And coming to application layer, which consists of different kinds of protocols such as HTTP, Hypertext Transfer Protocol, COAP, Coaxial Protocol, WebSocket, MQTT, Message Queue Telemetry Transport, XMPP, Extensible Markup Protocol, and DDS, Database Related Socket, and AMQP, Advanced Message Queue Protocol. Like this, multiple protocols are there which are existed. Now we will discuss about each protocol in detail and how these protocols are going to think. Coming to link layer, as I told you, link layer is the layer which is going to determine how the data is going to transfer physically from network layer by using that particular thing as a medium. And here, this is the layer which is going to determine how the packets are coded and how those data is going to be signaled by the hardware devices and how it is going to be attached. In the link layer, as I told you, 802.3, which is an Ethernet, which is a collection of wide Ethernet standards. And in this wire Ethernet standards, there are multiple things. 802.3, which uses a coaxial cable. 802.I, which uses a copper twisted pair connection. 802.3J, which uses a fiber optic. And 802.3AE, which uses a fiber cable. And by comparing to one to other, there is a high accuracy of data transmission which is going to be done with using of these cables. If you use coaxial cable, 10 Mbps per second. If you use twisted pair connection, 15 Mbps per connection. And if you use fiber optics, there is 99% accuracy. If you use fiber cable, 100% accuracy, like 10 gigabytes per second. So the data transmission rate is automatically, it was increasing very high. And we compare to the next one, which is 802.11, which is Wi-Fi. As I told you, it is a collection of WLAN communication standards in the link layer. And here also, there are different kinds of versions. 802.11 operates with a 5 GHz. 802.11b and 11G operates in a 2.4 GHz. And 802.11n, which is operated with 5 GHz. 802.11 5 GHz band, 802.11 6 GHz band, and the data rate 1 bits per second. Like this, multiple protocols are going to be used in link layer. And coming to the next one, WiMAX, which is a technology which is based on wireless broadband communication. In this, we officially called as WiMAX. What WiMAX is? Worldwide interoperability for microwave access. That is what WiMAX was. Worldwide interoperability. W stands for worldwide. I stands for interoperability. For Max, microwave access. What it is? Microwave access. AX stand for access. AXEESS. And this is the technology which is used for multi-point wireless technology. And see here how the data rate was 1 GB per second. If we use WiMAX, this is the structure. How link layer WiMAX layer is going to be setted out. And in the link layer, next, as I told you, LRW PAN, 2G, 3G, 4G mobile networks, and each protocol is able to transfer the data in different kinds of formats. If you observe 802.LJB, which is a Zigbee, which is a basically high level communication protocol, 40 KB per second of minimum data is going to be transferred by using this particular Zigbee network. And coming to 2G, 3G, 4G, where in 2G 9.6 kilobytes per second and in 4G 100 megabytes per second. This is the way how the protocols are able to transfer. And coming to the next layer, which is network and internet layer, and this was the layer which is responsible for sending our IP data from source network to destination network. For suppose I am texting some information and I want to transfer it to my friend. So I am acting as a source and destination network is my friend. This message has to transfer from source to destination in between these two devices which we are using, which we both are using. From these two devices, it should have an internet connectivity through the wireless medium of transformation. These things are going to be happen by using IP version 4, IP version 6, like this Wi-Fi low power wireless max. Like that we can use multiple things. And here the datagrams which we are using are going to used by depends on payload sector, and also it is using connectionless communication services here. And once if you observe what this network internet layer, how this is functioning is going to be setted out, IP version 4 and IP version 6, there is a small difference here which you need to observe. Have a look towards the diagram once. This is a representation for IP version 4 and this is a representation for IP version 6. And if you observe the differentiation, here in IP version 4, there is only 32 bits of information, which is 4 bytes. And if you observe 6, here this it is 128 byte address schema. See the differentiation, how the things are represented in hexadecimal activity in IP version 4. And also there is another thing which is, I told you, 6 LOW PAN, which is IP version 6 overhead, which is low power wireless PAN area network, which is going to act with a good frequency, 2.4 gigahertz frequency rate, which is like 240 KB per second. And the next layer, which is transport layer. As I told you, in transport layer, there are only two different kinds of protocols. One is transmission control protocol, another one is user datagram protocol. Here, this particular transport layer is going to provide end-to-end message transfer capability, and which is done independently in the underlying network without knowing to anyone. It is going to transfer one place to another place in the underlying network itself it is doing. And also here the things are going to be taken care, how the data is flowing, how the congestion, is there any congestion is happening, all these things are taken care individually. Here we are providing certain functions like error control, segmentation flow control, congestion control are going to be taken care apart. There are two types in this transport layer protocols such as TCP and UDP. TCP stands for transmission control protocol and UDP stands for user datagram protocol. Have a look how the things are. Transmission control protocol, and this was the protocol which is widely used in the transport layer such as HTTP, web browsers, hypertext transfer protocols, email, simple mail transfer protocol, and FTPs, file transfer protocols. There are some advantages as well as disadvantages of every kind of protocols which are used. In this network layer, there are only two protocols. One is TCP, another one is UDP. By using TCP, you are getting the advantages as it was a connection oriented and there is a reliable transmission of packets, and we are getting a handshake, and also we are knowing how error has been erased, and we also controlling the things like how the data flow was and how the congestion is going to be happen in the network. All these things can be controlled when we use this particular transmission control protocol. There are some disadvantages also in this transmission protocol. We are controlling, we are maintaining handshaking, everything, right? For due to that, there will be slow transmission rate, and also there will be more overhead. And if you consider with the next factor, which is UDP. UDP stands for User Datagram Protocol. It is an alternative communication protocol if you compare with TCP, right? And which is used to establish a particular low frequency and less tolerancy of connections between the application in the internet. By using this user datagram protocol, it is a connectionless protocol, and it transfers the data with a fast transmission, and here there is no heavy overhead. We are only having less overhead. Why? Because we are not getting any kind of acknowledgements. We are not maintaining any error flows, or we are not maintaining the control flows. For that purpose, there are some disadvantages such as less reliable operation error flow, no flow control, and no congestion control. These are the disadvantages when you compare with TCP and UDP. These are the two protocols which stands for like the same similar things are explained. Differentiating between TCP and UDP means you can simply say TCP is a connection oriented, whereas UDP is a connectionless. Obviously, in TCP it was very reliable, whereas in UDP it is less reliable. If you consider the error control is mandatory in TCP, whereas in UDP no error control is maintained. It was an optional. And here slow transmission, whereas in UDP fast transmission. Here more overhead factor will be there. Here less overhead factor will be there. Here we are maintaining the flow control and congestion control. There no need to maintain flow control, no need to maintain congestion control. The same things which we discussed previously, the same things are shown here for differentiating between TCP and UDP protocols like transmission control protocol and user datagram protocol on your left side. Have a look over there. This is UDP, user datagram protocol, and this is TCP. If you want to differentiate, these are the points you can specify. Comes under TCP and this one comes under UDP. And this was a diagrammatic representation for TCP and UDP. This is UDP. See here how the things will happen in TCP and UDP. Here this was TCP and this was UDP. Now see how the data transmission is aggregated. Here we are getting both end confirmations, handshaking process. Here we are directly receiving the things. No transformation will be there. See, this is how TCP and UDP is going to be. And the last layer, which is application layer. Here we are going to define how the applications and how the low layer protocols are going to establish, how the process to process communication will be happen by using the different kinds of port numbers, how the protocols are going to be done in application protocols. As I told you, there are n number of protocols which are existed in application layers, such as HTTP, Hypertext Transfer Protocol, COAP, coaxial like a constraint application protocol, and also WebSocket, which is going to allows full duplex communication, and MQTT, message queue telemetry transport, right? And XMPP, which is extendable message presence protocol, and DDS. As I told you, here it is related to data, which is D stands for data and another D stands for distribution service, DDS. And coming to the last one, AMQP, Advanced Message Queuing Protocol. Advanced Message Queuing Protocol. I thought COAP, which is coaxial. In network it was called as coaxial, but here in IoT it is a constraint application protocol, which is presented in application layer. Once have a look. And how HTTP is going to function by giving handshaking. Clients have sent some information and server is going to that handshake, which is going to allow half as well as full difference. Here it is a request and response client server protocol, and here the data is going to be transferred over the hypertext transfer protocol in application layer. And coming to the things how we are going to imply this HTTP in our IoT system. Have a look. This is how. This is a user interface. This was the smart gadget which is placed. From user interface, we are sending a request to this smart bulb, and this smart bulb is asking some information. Like this, the things are going to be maintained. And see here how this HTTP works in our IoT by using REST standard, as well as the architecture is going to be used here. With the help of this, the things are going to be done. And this is the WebSocket protocol, which allows full duplex by basing on TCP, which is a transmission control protocol which is open, and this is suitable for modern browsers such as Firefox, Chrome, and it is also allowing full and half duplex function. This is how, with the help of TCP and by IP in WebSocket, and by implementing this WebSocket in our IoT system, how the things are. It is very useful in a real-time communication, and it is very faster compared to the previous protocol. And see here, and there are different kinds of things, as I told you. MQTT, message queue telemetry transport, and this is a lightweight messaging protocol where we are publishing and using publish subscriber model. This is most widely used in our IoT applications, and with the help of TCP/IP, this is going to be run. Here we need a broker who is MQTT broker, who is going to publish our resources. Later on, the customers who are the clients are going to subscribe that particular things here. And here the things are maintained in quality of services with three different factors. First one is fire and forget. The second one is at least once you have to deliver. And the last one is deliver exactly once. These are the three different kinds of quality of service levels which are maintained. And this is how MQTT is going to be function. See how the broker is publishing the thing, and whoever the client requires, they are going to subscribe. They are going to subscribe your information, whatever is published by the MQTT broker. This is how the things are going to be happen. Once have a look in the thing. This is the MQTT broker, and he is one client, client 1, client 2, client 3, client 4. Whoever wants that particular published article, they are going to subscribe to that particular order. You can consider a real-time example like MQTT broker. You can consider him as Airtel distributor who is publishing different kinds of plans to you according to your requirement. Being as a client 1, I opted for 1199 plan. Being as a client 2 from distributor, you are opted for 699 plan. But based on your requirement and your subscription, you are going to subscribe the things. This is how, by using MQTT. And the next one is COAP, Constraint Application Protocol. In this constraint application protocol, here this is purely designed for M2M, which is machine to machine applications like smart energy, building automation. For these particular purposes, it is purely designed. And here we are using with constraint nodes as well as constraint network also, such as low power, low bandwidth, etc. And here it depends on request and response model. Whatever you requested, you are going to get some kind of response. Here the connection is between the client and client only. And this is going to support such as get, push, post, delete. These are the things which are supported by constraint application protocol. How this constraint application is going to be function in IoT, this particular diagram is going to tell. We are implementing DTLS, which is Datagram Transport Layer Security. Here we are using this security level for transferring an information, transferring a message through transport layer. And the last thing, which is XMPP, Extensible Message Presence Protocol. As I told you, X stands for extensible, which is an open source project. M stands for messaging, which is designed for a mechanism to compare with protocols. P stands for either the presence, what we call presence protocol. And this presence is going to tell you whether you are online, we are offline, we are busy, which is going to be detected by the presence. And coming to the last one, protocol, which is sets a standard for allowing system to communicate with each other. This is what XMPP was. extendable messaging presencing protocol. And this is how the things are going to be. And this is how the things are going to be. And the last AMQP. In this AMQP message, Advanced Message Queue Protocol, which is an open application which is going to support point-to-point communication. Here we are using publish subscriber model and also routing and also queuing. Queuing is nothing but one after another. There will be a particular queue which is going to be placed and these things are going to be served. Out of the queue, this is in and this is out. And whatever inserted, it is going to be addressed first, right? And here we are exchanging information and we are transferring information in form of a queue, and we are using binding connection. Binding is nothing but state the connection between different kinds of messages. This is how the things are: publisher and subscriber, AMQP broker, and these are the queues who are going to be addressed from subscribers. And DDS, data distribution service, which is a data centric service and which is happening between a device to device, which is a machine to machine communication. We are using publish subscriber model. There will be some publishers, there will be some providers, and the data is going to be distributed between publisher and server. This is how the DDS architecture was, how we are sharing, how the sensors and actuators are helping each other, how the data bus is accessed by basing on open human interface, enterprise integration, real-time analytics and control, sensors and actuators. And high-level abstraction. How high-level abstraction is going to be done? Based on distribution data space. See here, data writer. These are the data writers and these are the data readers. How the things are going to be happen. Here, the distributed data space is the thing where applications are autonomously read as well as written by them. And this is the logical design: application, management, services, security, communication, device. These are the things which are comes under logical. Device is the thing which is going to sense, actuate, monitor and control. Whereas communication block is the thing which is having different kinds of protocols in it and different kinds of layers in it. Whereas services, there are n number of services which are given by the IoT system, and we are using this management for doing n number of things to govern the IoT system. We require this management. And coming to security, we need to provide security for the authentication, in form of authentication, in form of authorization, in form of messages, in form of content, whatever you can consider. All those things comes under security for a safe data transmission. And coming to the application, we require an application to control our IoT system. For this particular purpose, these are the blocks. And that's it for today. In the coming class, we will discuss more about this introduction to IoT. That signing off is Sajja Suneel.
Like, share and subscribe. Hit the bell icon for more updates.